everyone, my name is Judy, and today I'm going to show you how to determine the basicity of an acid. So to do so, we're going to perform a titration. So we have this solution of a base of known concentration, so in this case it's sodium hydroxide, and by determining the volume of the base, sodium hydroxide, that is required to exactly neutralize a known amount of the acid, which is hydrochloric acid in this case, we can calculate its basicity. So we're going to do that by performing a titration. This is the first of many titrations that you're going to perform in this course. So it's good to get familiar with the techniques and the equipment that's used. So anytime we're performing a titration, we need two main pieces of equipment. The first is a burette. So this is your burette right here. Okay. It has graduations, of course, on the front. Starts at 0 at the top and goes down to 50 milliliters at the bottom. Okay. It has a stopcock at the bottom, so when you turn this parallel to the burette, it's open. When it's perpendicular, it's closed. Okay. And it fits into a burette clamp to hold it in place for the purposes of our titration. The other thing we're going to use is a volumetric pipette. So you should have used these before, probably in first year chemistry, but I'll take you through how we're going to use it again, just to refresh your memory. So anytime we're using a burette or even a pipette, we want to make sure everything is clean. So in order to make sure a burette is clean, we can start by just rinsing it out with some deionized water. So I have a waste beaker here that I can let the water flow out into. And as I rinse it, if any beads of water or droplets of water stick to the inside of the glass, then I know it's not clean. So if it's not clean, I would go back and clean it with soap at the sink. But this one I've already cleaned, so I know that it is clean. So if I've rinsed it with water, my next step is now to rinse it with the solution that it's going to be filled with. So in this case, the solution in your burette is going to be our sodium hydroxide solution, our base. Okay? So now that all the water has poured out, I'm going to add some base to it to give it a rinse. So I'm going to use a funnel to add my sodium hydroxide so that I don't spill any. So I'm just going to pour a little bit in. Just enough to rinse it. It's probably about 10 milliliters or so. I'll take my funnel out. And to rinse it, I just rotate it so that it covers the inside of the burette. So you let it pour down through. Okay. You do that a few times. Ideally, you should be doing this over a sink in case you spill it, but for video purposes, I'm just going to do it here. And we'll just let it drain out into this little benchtop sink. So you want to make sure it's rinsed really well. So you rinse it at least 3 times with deionized water, and then 3 times with your solution that you're going to be using. So I've already rinsed this one. So this one is nice and clean now and ready to go. So I'll put it back in my clamp. So when I'm ready to start, I want to fill it with my sodium hydroxide solution. So when I fill it, I'm going to make sure that it is somewhere below the 0, because the scale on this one moves down. So it goes from 0 to 100, or 0 to 50 as we move down the burette. So it has to be on the scale, of course, or I won't be able to get a reading of what the volume is. So I want to fill it so that it's somewhere below the 0. You don't want to worry about getting it exactly on the 0 or even close to the 0, because it really doesn't matter where it is. You're going to record that number, and that's what you're going to use as your initial value for your titration. So when you fill it up, it's very easy for air bubbles to get trapped in the burette as well. So you always want to let a little bit pour out into your waste beaker to make sure that there's no air bubbles trapped in your solution. Okay. So we're ready to go here now. So now we're going to take our initial reading. So it's important when you're reading a burette that you're at eye level with the level of the solution that you're reading. So the level of the solution here is right about here, so it's at about eye level with me. So it's easy to lower your burette to get at eye level. So when you're taking a reading, I'm just going to turn this so the numbers face me. We can read 2 decimal places off of this burette. So I'm looking directly at it, straight across, and I'm going to read where the bottom of the meniscus hits the scale. When you're taking a reading of a meniscus, especially when we're in a lab, there's windows behind us, sometimes it's hard to see exactly where that meniscus is. It helps to take a solid sheet of paper, and put behind it so that you can see it more clearly. So when you're taking a reading, now you can see it close up. I'm just holding a sheet of paper behind it so I can see it more clearly. Sometimes when you're looking through and there's lots of obstacles in the background, it can be hard to get a good reading. So if I can manage to hold this steady here now and get at eye level, you'll see that we're at about 0.6, and we're just below the 0.6. So I would estimate that at about 0.62. So that is going to be my initial reading in my titration results. Okay, so now that I have my initial reading taken, I can start measuring out my acid. So I'm going to use a Erlenmeyer flask for my reaction flask. So this is the one we're going to perform the titration in. So to that I want to add my acid. So we're going to use 10 milliliters of acid in this case. So we're going to use a volumetric pipette to measure out the acid. So again, like with the burette, you want to make sure that this is rinsed really well with the ionized water. Okay, so I've already rinsed this, but I'll just rinse it again. And let the water pour out. And again, if there's any beads of water that stick to the inside, then it's not clean. You need to go back and wash it with soap. Then we rinse it with the solution that we're going to be measuring out. So in this case, it's our hydrochloric acid. So we're going to take some of that solution up. And we'll take off the bulb. Give it a little rinse, and again, you should ideally be doing this over the sink, but for video purposes, I'm going to do it here. And let that pour out. So now it's all rinsed out with the solution that you're going to be using. So there's no water left in there that will affect my concentration of the acid. So when you're using a pipette ball, remember you want to put this on so that it's secure enough that the pipette doesn't fall off, but you want it loose enough that you can easily get it off and put your finger over the top. So remember when you're doing these titrations, to get the volume right on the line, you take the bulb off and then you use your index finger and just rotate it slowly. And that allows a small amount of air to get in so that your solution comes out and you can get a more accurate reading, more accurate volume. So I'm going to take up 10 milliliters of my acid solution. So I'm going to let it come up so that it's a little bit above the line, because you always lose a little bit when you take it off and put your finger over the top. Okay, and I lost a little bit too much, so I'm going to do that again. And this is one of those things that even the most experienced chemists struggle with getting it exactly right. So don't feel bad if you have to do it a few times. So I'm just going to rotate this now to let some of the solution come out until it is on the line. Okay. And you probably can't see this, but it's going down slowly as I'm doing this. And then I can stop it when it is right on the line. And you want to be at eye level with that line. There we go. So that's exactly 10 milliliters. So I'm going to let this drain out into my flask. And when I do that, I'm just going to hold the tip of the pipette against the edge of the flask. Okay. And let that pour out. So with titrations, you want to be very accurate with your volume. So that's why we're using volumetric pipettes and burettes, because we want to have a very accurate volume. Okay, so that's our 10 milliliters of hydrochloric acid. Okay, and to that I'm going to add my indicator, and our indicator in this case is phenolphthalein. And this indicator is used because it changes color with a change in pH. So when our reaction reaches neutral pH, the color of the indicator will change to indicate that, so we know when our endpoint is reached. I'm just going to add 10 drops of our indicator. Let's give that a little swirl to mix. Okay, now I'm just going to move my burette up a little bit so that I can get the flask underneath. I'll move my waste beaker. Actually, before I move my waste beaker, I'm just going to spray around the tip of the pipette just to get any excess solution off so it doesn't fall into my solution and affect my results. Okay. So when we're ready to do a titration, it's been a little while since I took the initial reading, so I always want to double check that and make sure it's the same as what it was when I started, and it is in this case. So when I'm ready to actually start my titration, a good technique for a titration is to hold the stopcock with your non-dominant hand. So I'm left-handed, so I'm going to hold it with my right hand, and then swirl the flask with your left hand. So if you're right-handed, obviously it would be the opposite. And as you turn this, you can really adjust the amount of solution that comes out fairly precisely. So if you turn it all the way parallel, it comes out very quickly. Okay? And if you turn it slower, you can really get it to come out one drop at a time. Okay? You can even get a half drop by having a drop that's hanging on the solution, and then as you spray it with water, it goes down into your solution, and you can consider that a half a drop. So your first titration, when you first do it, right now I have no idea how much I'm going to need to add. Okay? So I don't have any idea, so it's going to be a trial one. So the first one, we call it the rough titration, because it'll give you an idea of how much you need. It won't be an exact titration, but it'll give you a general idea. So we generally let about a couple mils at a time pour in and keep swirling. So you see how it changes purple as I'm swirling, and then it goes away again as it mixes in. Okay, so I'll let that go. So I'm just adding a couple milliliters at a time and swirling. And I do that until I start to see that color stay a little bit longer. To help you see that color a little more clearly, I've put a sheet of white paper underneath the solution. It's easier to see against a white background than a black background. So you can see that the color is changing, and then as I swirl, it goes away. It stays a little bit longer now, so as it starts to stay longer, I'm going to slow down and add my solution a little bit slower, so you can see that if I stop for a second, one drop at a time. One drop, swirl, one drop, swirl. And when I start to see that color stay, which is right about here, that bright purplish fuchsia maybe color, we can see that the color is staying, so that means our reaction has reached completion. So this is probably a little bit overshot. Okay, so if it's dark purple like that, it's probably a little bit over what I would expect it to be. But again, this is my rough titration. So this one will just give us an idea of how much base we need to add, so that when we do the next two more accurate ones, we'll have an idea of about how much we have to add, so we can get a better accurate volume. So now that we've reached the end point, we're still going to record the burette reading for this titration. So if we look at the burette scale here now, so this reading, again, we're reading down the scale, so it's 10.4, and that looks to me like the bottom of the meniscus is directly on that 0.4. So I'm going to call that 10.40. Okay, so that reading is our second burette reading, and to get the volume of sodium hydroxide that we added, we're going to subtract that first reading from the second reading, and that'll give us the exact amount that we added from the burette. So that's going to be our volume added for our first titration, which is our rough titration. So now we're going to get ready and do two more accurate titrations. So for our next two titrations, we still need our burette with our sodium hydroxide in it, so I don't need to fill that again. There's still plenty left. So I'm just going to put this flask to one side and take a clean, dry Erlenmeyer flask, and we're going to put another 10 milliliters of acid, hydrochloric acid, in that flask using our volumetric pipette again. So it's already been rinsed, so I don't need to clean it again this time. So I'm just going to do the same procedure, fill it up so that it's a bit over the line. Hold your finger over the top. We're going to add eye level, rotate until it comes down to the line. And again, this is one of those techniques that takes practice. As you get more used to doing it, you can do it faster and faster. We'll let that pour out into our Erlenmeyer flask. And then to that, I'm going to add my indicator solution again. 10 drops of the phenolphthalein. Again, I'm holding it against the edge of the glass so that we get that last drop comes out into our flask. We don't lose any. Okay. So now that we have a rough idea from our first rough titration, it took about 10 milliliters, not exactly, but about that. So that means that I'm probably safe to pour out about 8 milliliters from our burette into our solution, and then we can slow down and add it drop by drop so we get closer to our end point. Okay, so again, I'm going to take my initial reading, my first burette reading. So again, I'm going to hold something behind it so I can see it, and it is 10.38. Okay, so that's going to be our first burette reading for a second titration. So I'm just going to add fairly quickly about 8 milliliters or so, because I know about what it's going to be. As I get close to that, then I'm going to slow it down. Okay, so I didn't go over because you can see that my solution is still clear and colorless. So now that I know I'm fairly close to my end point, I'm going to slow it down and just add a drop at a time. Just 2 drops. And we should see the purple color start to stay a bit longer. And then we know we have to slow down even more. So the most important component of titrations is patience. You don't want to rush it. Sometimes we're in a hurry to get things done. It's very easy to go over, and it really doesn't speed things up because all it does is make you have to do it again. See, every drop I add, the color stays a little bit longer. And when it starts to stay more consistently, instead of adding more, what I'm going to do is just take my distilled water bottle, and I'm just going to spray off the tip and around the insides of the flask and mix that in. And now you can see that we have that nice pink color. It's staying around, okay? It's lighter than the last one, so that is the ideal endpoint color we're looking for, just a pale pink. Okay, so now we're going to record our burette reading for a second titration. So our second burette reading for a second titration. Okay, so reading our burette, we are at 19.9, and it's just slightly below the 19.9. So 19.92 for that reading. And now we have to do one more titration. So that was our second. We'll do one more, a third titration. So we'll put this flask aside. We'll get another clean, dry flask. And again, we're going to add our 10 milliliters of hydrochloric acid. Using our volumetric pipette. Same technique as before. Eye level. Twist it slightly just to let the solution come down. Coming down slowly. And we stop when it's on the line. There we go. Pour that out into our flask. Then we'll add our indicator again. And we still have about 20 mils left in our purette, so we don't need to top that one up again. Let's add our indicator. Slow this down. And we want to take our initial burette reading again. So we could have possibly lost a little bit of solution during the transfer, so you want to always take your reading again to make sure that it stays the same. And then once we have our reading, we can start our titration. Okay, so we're ready to start our third titration. And like last time, we have an idea now of about how much it takes. So I can add about 8 milliliters or so. Usually you want to go about 2 centimeters shy of the amount that you estimate it's going to take. Okay, so that's about 8 milliliters. Now I'll slow down the flow rate to drop by drop and add it to my acid solution. So you see it's turning purple, it's starting to stay a little bit longer. I'm going to slow it down. Okay, one more drop. And it looks like that is our end point there. So you always want to make sure the color stays, because sometimes it can fade away. So you want to give it 30 seconds or so, make sure it stays, the color stays, and then if it does, you've reached your end point and you take your final burette reading. Okay, so our last titration is done. So the last thing we have to do then is to take our second burette reading for a final titration. So we're going to read that off the scale and record it. And when you're doing titrations, the first one, of course, was a rough estimate, but the next two, for our purposes for this lab, we want them to agree to within 0.05 of each other. So when you calculate the volume added, they should be within 0.05. If they're not, don't worry about it. You can always just go back and do a third titration, maybe even a fourth if that's required, hopefully not. But we can always do more titrations until we get values that are close to each other. So that concludes this lab. We will send you out the results, and you can use those results to put into your calculations to determine the basicity of the acid that we tested. Thanks for watching.